All right, welcome to the Explainer. Today, we're going to tackle a technology that's powerful, world-changing, and let's be honest, famously confusing, the quantum computer. Look, if that sounds familiar, you are so not alone. The public conversation around quantum computing is so tricky to follow that even experts get frustrated with how it's talked about.
So let's actually figure this out. We're going to go on a little journey here to understand what they are, how they work, and most importantly, why they matter so much.
All right, so let's just dive right in. And the best way to do that is to start with what a quantum computer isn't. Okay, first things first, and this is probably the most important thing to get your head around. These machines are not just the next souped-up version of your laptop or some giant server farm. That's a really common mistake. Yeah, calling them just faster is honestly the biggest hurdle to understanding them. It kind of misses the whole point. The reality is they're a completely different beast, a new kind of tool, built for problems that our current computers, well, they just can't even touch, no matter how powerful they get. And to really make this stick, there's this fantastic analogy that just makes it all click. Okay, imagine solving a really tough math problem is like trying to explore a huge uncharted map. For centuries, right, which is pencil and paper, we were basically walking. Then, boom, early computers come along and suddenly we have horses. We can go way further, way faster. And today's supercomputers, man, those are like Ferraris just screaming across this landscape. So here's the big reveal, the key to all of this. A quantum computer isn't a faster car. It's a boat. It's not about improving how we travel on land. It's about a whole new way to travel. And when you stop and think about it, that makes perfect sense, right? You'd never take your car to cross the Atlantic, and you're not going to drive a speedboat down the interstate. They are completely different tools for totally different kinds of terrain. Okay, so if it's a boat, what does one of these things actually look like? What's inside? You know, when most of us try to picture a quantum computer, we kind of draw a blank. Or maybe you picture that one famous photo, right? The big golden dangly thing that looks like a crazy futuristic chandelier. Well, here's a fun fact. That thing, that golden octopus, that's not actually the computer. Not really. It's a huge, incredibly complex cooling system, a dilution refrigerator, and its only job is to get the actual computer cold enough to work. And when I say cold, I mean unbelievably cold. The quantum processor, which is just this tiny little chip at the very bottom of that whole contraption, has to be kept at an insane 15 millikelvin. So what does 15 millikelvin even mean? Well, to put that into perspective, it's colder than deep space, colder than the empty void between galaxies. We're talking about one of the coldest spots in the entire known universe, created right here on Earth just to make this thing run. And the reason for all this extreme engineering comes down to the machine's most basic parts. Its building blocks are nothing like the simple bits you'd find in your phone. So your laptop, your phone, everything we use now runs on bits. And a bit is super simple. It's either on or off, a 0 or a 1. That's it. But quantum computers, they use qubits. And a qubit, well, it isn't just a 0 or a 1. It's kind of a probability of being both at the same time. And this leads to another huge myth, that they just magically try every answer at once. It's not quite like that. A better way to picture it is to think of these qubits as ripples on a pond. The computer sets them all in motion, and then it just watches how all those ripples interact, how they interfere with each other to see where the most probable answer will emerge. Okay, so if these things calculate in this totally weird, wavy way, what are they actually for? What kind of problems are we trying to solve with our new boat? What's actually in this quantum ocean we're exploring? Well, one of the absolute biggest game changers is simulating nature. I'm talking about the molecular level. And here's why that's so cool. Nature, at its core, is quantum. So by using a quantum computer, we can speak its language. We could design brand new batteries, create materials that we can't even imagine yet, or discover new medicines by perfectly modeling how molecules will interact.
But there's another big one, a much more urgent one that has governments and security agencies all over the world in a flat-out race to build one of these things first. You see, the math that protects basically all of our secrets online, your bank account, your private messages, all of it, is called RSA encryption. Now, if you took the world's most powerful supercomputer today and told it to crack that code, it would take billions of years. Billions. But a big, powerful quantum computer, it could theoretically do it in hours, maybe days. The implications of that are just staggering. So this incredible, almost scary power, it really shows us that we're standing at the dawn of a totally new age of computing. So our analogy has to evolve too. We're not just building boats to cross the surface anymore. We're building submarines. We're getting ready to go deep and explore this bottomless ocean of problems, of scientific mysteries we haven't even thought to ask yet. And at the end of the day, this isn't just about building faster gadgets. It's about something much more fundamental, understanding the universe we live in. As Olivia Lane from IBM said, part of the human experience is you just want to learn more about the world we live in. And the fact is, the world is quantum mechanical. We're building tools to finally understand reality at its deepest level. The potential here it's truly mind-boggling. We're just beginning to dip our toes into this new ocean. We have no idea what wonders or what dangers are waiting for us down in the deep. We're just skimming the surface of a bottomless ocean. So the real question is, what are we going to discover next?